Okay, colleagues, we are continuing the track. Couple small announcements. If you're already getting hungry, then you can stop by the university cafeteria. You can find the route on the maps that are available, or just follow the signs from the main entrance. The other option is food truck that will be available from 2 p.m. So right after this presentation is over. And now I will be passing the floor to Ilya Etingof and Dmitry Tantsur. And they will tell you what they will be talking about.
Hello, and welcome to the RedFish talk. It's lunchtime, so we're going to serve you the RedFish. In this talk, we're going to tell you about the hardware management concepts, the background, the motivation, the history behind it. And we will expand on that, telling you more about the most recent development in this area, the RedFish protocol. We'll talk a little bit about its use cases, applicability, and possibly the future. Initially, we were planning to do the live demo, but as it goes with live demos, it never works, and it may not happen. But we'll try. Let me start with a story. Imagine you are a system administrator at a large company, and you're entrusted a very important application. Now it's late night, and you are in your bed, and you're deep sleep. Suddenly, you get a phone call. That is a shift engineer. They're telling you that the application you're responsible for is not behaving well. They're receiving complaints from the customers. You jumped out of your bed, you reached out for your computer, you hopped on your company's network to find out that the application is indeed dead. You're trying to log in to the server, but you can't. Desperate, you're trying to understand what's happening, then you get another phone call, this time from your manager. They are very concerned about the situation. They are almost freaking out. They explain that they receive enormous pressure from the customers and from their superiors. You can't really explain to them what's happening, so in the end, you get 10 minutes to fix everything. So what do? Luckily, you are a wise and experienced system administrator. You have done your disaster recovery homework ahead of time. So you have some kind of hardware management system in place at your disposal. You used it to get on the console of the faulty server to find out that it's indeed a data corruption problem. You change the boot order of that server to make it booting from the network. You logged in, you recovered the data from backup or somehow else, booted back from local drive, and the service is basically back to life. End of story. The point behind this story is to show you, to convince you that having some kind of hardware management, some kind of remote access to the hardware can be a lifesaver. The other important use case when hardware management is a game changer is when you run a large fleet of servers, maybe in a private cloud. At large companies like Microsoft, reportedly, their server count hits 1 million. It kind of implies that having so many units running around the clock makes them come and go. They break down, you need to upgrade them, you need to phase out the old ones. You need to repurpose them and maybe page them massively. So having some kind of automation aligned with the life cycle of your hardware can lead to huge savings in time and money. Now, about how it works, what is that hardware management thing? At the heart of it lies a computer. At the heart of a hardware management system lies a computer. It is frequently referred to as BMC, which stands for baseboard management controller. This is quite an old term. It's not, it doesn't reflect what the state of the things now, but it's still with us. It can be a single chip, system on chip, soldered on the main board, or it can be a standalone computer. In any case, there are two important things about the BMCs. Firstly, the BMC is completely independent from the main system. It can run independently. It doesn't matter in which state the main system is. It can be completely dead or completely alive. Secondly, the BMC usually has hardware electrical connections over various hardware buses to the crucial parts of the main system, what gives it complete control over the main system. Inside the BMC computer runs a software agent, which implements the hardware management protocol. This talk is about RedFish. RedFish is one of those hardware management protocols, the latest one, the most advanced probably, and it's very new. It was signed into the standard in 2015, and it's keep developing. But RedFish is not the only protocol we have now. The immediate predecessor of the RedFish is known as IPMI, the Intelligent Platform Management Protocol, or interface. The IPMI protocol was designed 20 years ago for the low-powered computers of the time. It was designed as very efficient on resources. It has low footprint on resources and on the network. But on the other hand, it's harder to use, it's harder to learn, it's hard to debug. The scripting with IPMI is a pain. And when we're talking of hundreds of thousands of servers, it doesn't scale well. Additionally, on top of that, at some moment, the IPMI functionality started to lag behind. That probably explains why almost every hardware vendor on the market came up with their own hardware management protocols. And now we have many of them. As Andrew Tannenbaum put it, the nice thing about the standards is that there are so many to choose from, but it doesn't quite apply to hardware management, because if you are a data center operator, you can't really stick to one of those protocols because you tend to source different hardware over time. So you might end up having all those tools and all those protocols to support. By the way, there is a protocol which is a vendor-specific protocol which is designed by HP, and it's called Integrated Lights Out Manager. So I have a question to the audience, if anyone knows why it's called lights out. It doesn't sound like a good thing when lights are out. No clue?
Nobody's in the data center.
Sorry?
The lights are out in the data center.
Yeah, exactly. Right. So the idea behind that is that when you have a fully automated data center, you don't need any human beings there. And therefore, you can just turn all the lighting off because computers can write in full darkness, can run in full darkness. So this is the state of things with BMC. But it used to be worse in the past. Before the BMC technology arrived, people had to use the various hardware hacks to gain remote access to their hardware. For example, they used the so-called KVM switches, and that KVM has nothing to do with a kernel virtual machine. That stands for keyboard, video, and mouse. The serial consoles, they used to hook up especially Sun hardware to the network server over serial lines and have access to boot manager. They used even remote circuit breakers to flip power remotely on the servers. And of course, people used in-band, so-called in-band access, like SSH, VNC, RDS. but the problem with in-band access is that it doesn't work if the main system is not feeling well. But it used to be even worse in the past. People, the businesses running the data center, they were forced to keep a living soul at the data center at all times to do something about that. I personally started my career in computing many years ago as a shift engineer at the data center, and that job involved being at the data center for 24 hours and sleeping on a folding bed in between the roaring, cooling, heating, vibrating racks stuffed with servers. And I remember that I had to hug that bulky pager at night instead of my young and lovely wife back then, because of all this noise. You can't really hear the beeps. So I can appreciate the development of all these things. So much for the history. So what's the RedFish? To put it simply, in technical terms, RedFish is a web service. It communicates with the clients or communicates the data with the clients over JSON serialized documents. The JSON documents, they are hardened with the open data schema. The web service is designed to be human-readable, human-friendly, and kind of self-documented, discoverable. And the service is designed to be able to manage multiple hardware entities at once. The RedFish itself is not a groundbreaking development, although, in my opinion, its power lies in, hopefully, universal adoption, and secondly, in the tooling and technologies it bases itself upon. And those tooling are all about web. This is a web service. It uses TCP IP and HTTP and JSON. And of course, we are all familiar with that, and all the automation we have, it's built in. The RedFish, conceptually, RedFish consists of a couple of major components. The resources is the way to represent the hardware in RedFish. The clients of RedFish can apply operations on resources to get the information or to change them. And additionally, RedFish has this concept of services, which are kind of additional applications running on top of all these things. And these applications are just handy. They're not necessarily directly relevant to the hardware management. We will touch that services a little bit later. Speaking of resources, RedFish tries to model all the manageable properties of the hardware in form of REST API or REST API resources. The systems group of resources models the servers. The servers at the data center, they tend to be mounted in racks or, in case of blade servers, in enclosures. The chassis endpoint or the chassis resource models the racks, basically. And finally, the manager's endpoint and resource, it represents the BMC itself, the hardware management system itself. What's important about all these groups of resources is that they are hyperlinked to each other. That makes it possible for clients to reconstruct the physical layout of the data center by just crawling the web service. And this is where we were planning to start our demo, but it's probably...
I can try it.
Okay.
I can introduce what I'm going to show.
All right. So we're going to show you how it would work if we would have a RedFish enabled hardware as a web service and the client.
Yeah, we're showing it on the virtual machines and thin between libvirt and RedFish protocol.
How many
HP, all new generations are RedFish enabled. iDRAC as well. Fujitsu is looking into it. I'm not sure about Cisco. Yes, Cisco, yes.
So anything in the last 2 years maybe? Or?
Yeah, maybe a year or 2 years. HP was the first. They were part of the committee which developed the thing. I think Dell connected later to this effort, but newer generations are RedFish enabled for this.
So, sorry to interrupt. So in HP, new generations mean from generation
10, Gen 10.
Gen 10, which is actual one. Yes.
Sorry?
That's the latest one.
Yeah, yeah. ILO 5 and...
Hold this. It's... Ничего не видно. Should raise it a little bit.
So this is the root endpoint. I just have handy scripts to connect to a local host where this emulating software runs, which bridges between RedFish and libvirt. So this is the root. We only support systems. There's no chassis or managers. At least I didn't implement it last night. So here we see there's a lot of like verbose things about OData standard that defines the structure we're reading. So essentially, you don't have to hard code it in advance. You can discover the schema, discover all relationships. Though it may be a bit bulky, so some people tend to avoid it. We have a systems list. No, it's not a list. It's just a linked systems collection. So when traversing from root endpoint, we can then move to this RedFish v1 systems thing. And if you notice, we had 3 VMs, and you see these 3 VMs as members of the systems collection. So each represents its own system. Their names become their IDs and their URLs. We can try getting any of them. It's actually a stripped out version that only lists things, more or less lists things that make sense for virtual machines. The real hardware will have much, much more. And I need to say that nearly nothing is mandatory in the standards, only ID and name. This may be seen as a downside of it. You have to discover what is available. Here we implemented, we use this too in the CI, by the way, for our product. We implemented boot management, boot device, power state. Yes, of course, there's ID name, UUID. We have, I will talk about OEM a bit later. We have processor summary, and we have links to next collections. Of them, I only implemented Ethernet interfaces. And then another thing that Ilya is going to talk about a bit later, actions. So what you can do with the thing. So we have one action, which is power action. We'll come to it a bit later. Let's go down to Ethernet interfaces. I hope it's going to work. Okay, we see that Ilya has 2 virtual NICs for this system we're looking into. I'm just using their Macs as IDs. On a real hardware, probably have some more specialized ID, not a Mac, because Mac can be changed, obviously. But we have what we have from libvirt. And finally, if you see, I'm following these links that are written here. So that's why I'm saying you can traverse the whole thing. Oh, where am I? Okay, what's... And that's, again, for a real network adapter, there'll be much more information here, but I only could figure out MAC address just to show you how it's going to look. We have MAC address, some fields generated from it, and you always have the ID of the current resource we are looking at as all our resources. And we have its schema definition and OData format and namespace and everything like that. So when I talk about actions in power state.
Okay. Obviously, you can not only read the data from the web service, but you can also change it. And the changes to the resources of the web service propagate and apply to the actual hardware. And that way you control the hardware. RedFish defines two ways to change the resources. For RESTful operations, RedFish uses HTTP methods directly. For example, you can change clients can change the boot order of the server by modifying the boot configuration of resource, basically. And this is the example. But not all operations are RESTful. For instance, when you want to apply multiple changes to multiple resources at once, or if you want to do things like booting the machine, this is not RESTful. And for those cases, RedFish introduces the concept of actions. Actions can be applied on resources, and they're not RESTful. We have this example how to boot the machine. By applying the action on the power on property of the resource, of the configuration, of the state.
This is the tricky part, right?
Yeah, it doesn't work. Okay. We can blame the VGA problem, video problems. Because we prepared the demo on the other computer, but we can't connect it to the projector.
Yeah, actually, we don't have a network that is defined for this VM.
All right. So sorry, but the thing is that there are those actions you can apply on the resources, and you will basically do the thing that you want.
I could just add a summary about that here. So it also happens on real hardware when the system is still booting and needs not initialized, because until it's not initialized, it will give you the error. Just part of implementation. Because the web server is not booted properly, or it's still booting, and you get that error.
Yep. Okay, so it's very reasonable state of the things. All right, you remember that if we get back to the slides, maybe. Let's skip this. Yep. Okay. So the last thing I wanted to talk about is the services. So RedFish has this concept of services, and those are like additional applications, quite random applications that the vendors can put inside the RedFish agent to facilitate its use. The core RedFish schema defines a handful of those services. For example, there is this task service, which is used by the RedFish agent to run and maintain asynchronously executing operations. When a client requests an operation which might take time, RedFish agent may decide to create a task within itself to put that operation inside this task and give out the client the status URL to eventually get the outcome of this task, of this operation. As a web service, RedFish supports user authentication. Of course, the basic HTTP authentication is built in, but besides that, RedFish supports the token authentication or web sessions. For clients that want to use web sessions, they can request the session service for a web token and use it for subsequent queries. Once user authentication is on the table, we would need users. The account service within RedFish agent is designed to create and maintain the user account that can access the RedFish service, the RedFish agent. And finally, there is this event service within RedFish, which works like an alerting service, because sometimes resources, a state of the resources can change behind the scene. So some clients may want to be notified about the changes to the resource. In that case, that interested client can register its own REST API endpoint with the event service at RedFish agent. And then when something changed to the resource, the RedFish agent will call back the client and report the new state of the resource. And I'm going to pass the mic to Dmitry to talk about the extensions and future development of the RedFish.
I think it should be fine. I'm quite loud. Am I? Okay, cool. 1 second. Anyway, so first about extensions. As I mentioned, extensions is one of the selling points of RedFish. And of course, I have a lot of hardware from different vendors with some history of developments, with some features that they just have to keep exposing to users because that's what we did forever. And one size will never fit everyone. So the way of extending RedFish is built in the very protocol, and it's a short version is you can extend everything. Nearly every resource, and even some things like actions or collections, they can have an OEM field inside of them, which is a JSON object. And inside that, you have a vendor-specific namespace. So in this example, for example, taken from the DMTF website, they have two fictional companies, Contosa.com and Contosa.biz. And you see .com is stripped, so we end up just Contosa, and then inside of it, there are specific fields. That's, for example, that can be put on a system resource. Oh, what the? Is red now? Okay, cool. So this is their specific fields. For example, this whole structure can be put on a system, or in a chassis, or even the root of the whole URL tree. And then Contosa.biz adds their own field. They take care to make sure they never overlap. If, for example, two vendors of this a system can have many vendors, right? You have, I don't know, motherboard, processor. Maybe that's not the best example, but potentially a single entity can be provided by several vendors, and they can have several extensions. But in most of the cases, you have one vendor per resource, and they will provide some additions here. What is important, probably already clear to you, that actions can also be extended. Inside of actions object, which you saw, for example, in the system, you have power action. You can have, again, OEM. You can have their a bit fancy names. They can describe which URL you use to execute this action. As you see, you also have action/OEM, again, to avoid collisions between URLs. It can have parameters. We don't have them here, but they can be defined here. You remember those allowed values for power action in our generic example. And as I said, you can even put OEM field in the root and define new top-level collections. That's quite possible. Of other interesting things, it's not even future. Some of it is actually present. But OK, people realize it's a very convenient framework to model hardware and all its aspects. So we can model not only power state, inventory, and other things we can model. Can do storage, network, and compose hardware. So storage. RedFish actually defines two kinds of them. There's simple storage, which is a sub-collection on systems, and merely lists disks with quite a few details of each one. And then there is a more complex family of resources. They can, first of all, they can create storage. So, for example, can create RAID, and they can describe RAID systems. So, which resources we have? We have storage as a set of controllers, for example, SATA, RAID. We have drives, which are the physical things that you have inserted in your server. They are represented here. And then we have volumes. Volumes are things that are exposed to your operating system or to your virtual machine in case of a hypervisor. And there can be one-to-one mapping between a volume and a drive in the simplest case, which is just a drive just exposed to the operating system. But it can be a volume, can be combined from several drives by building mirroring through RAID. And that can be done through RedFish API. That's a big cool thing about storage thing. And then there is a separate standard which is called Swordfish, which is built on top of RedFish to also define remote storage. Right? In a data center, you often have not only local disks, but you have the SANs. These are just computers, like specific but computers as well. You can call them a system. Then you can provide storage systems, which specifically systems that do provide storage. And you have storage services. Again, you have volumes, drives, but all this working remotely now. In a similar fashion, you have your data center, you have switches, you have a lot of fancy network devices that most often are more expensive than any of your servers. They are computers, quite sophisticated. You can represent them as a system. Wonderful. Another addition on top of RedFish. They combined these concepts we talked about, systems, chassis of a switch, with an existing standard called YOUNG, which defines network properties, so specifically related to network device. And what they did essentially is they just took this YOUNG thing, they converted it to something more resembling RESTful API and just attached it under network devices collection in the root API. So now you can use the same RedFish with the same features, but to control network devices. And the last but not the least, and this thing is giving a lot of noise recently, actually. System composability. The thing is, you no longer have, like we used to, this is hardware, right? This is my laptop. But what they want to do, they want to represent your hardware as just a pool of resources. Processors, memory, storage, some network capabilities, and build your system, so create a logical hardware. So this is what they call system composability. From a pool of resources, of physical resources, you get a machine with parameters you want to. And again, through RedFish API. Wonderful. It's part of the standard, I think already. You have a new service called composition service, which does this magic. I have resource blocks, which is units of hardware, indivisible unit. And then you have resource zones, which are a relationship between these blocks, saying which blocks can be combined together to produce a machine. And this results in the fact that you can create a system. So you can post on systems collection, just as you do with HTTP API, to create a system just by specifying a set of resource blocks and a name and maybe something else. OK. Challenges and problems to wrap it up. RedFish is still getting adoption. It's moving quite well, but still it has to be seen if we're going to end up with this XKCD comics about 14 competing standards, or it's going to be really a solution like APMI, which you expect to see in more or less every sane enterprise hardware. Feature bloat, it has a lot of features already. If you look at the schema, we only listed the main things, the most interesting things anyway. There are already dozens of objects in standards. There are at least 2 big extensions to the standard. And then you can have OEM extensions as well. So there's a tendency to add more and more and more. And a problem with extensibility is that there's also a tendency to not standardize everything because they can just put it in the OEM. And the third problem, which I mentioned above, very few things are mandatory in the standard. So you have to discover what you can, because you can have a completely compliant RedFish implementations, which essentially have systems with names. Not quite useful, but that's OK. Fortunately, vendors don't do it. I hope they won't. And extensions can be not quite compatible. So if vendors go down an extension path, and then you have to use it, you'll get back essentially to the situation of different protocols, because this vendor implements this feature this way, that one didn't implement. So DMTF is doing quite a good job standardizing the most important things. So in the beginning, there was a lot of extensions. Like RAID was an extension. And I was talking to people from, I think, Dell and HP, like, are you planning on having RAID and RedFish? And like, well, so a year and a half passed, we have a RAID in the standard, so it's probably not going to be a problem anymore. And yeah, I'll probably pass it to you.
So we have this OpenStack booth over there. And at that OpenStack booth, we have a Raspberry Pi based prototype of the RedFish agent controlling the actual hardware, the actual server, the Intel NUC. Everyone is welcome to visit us there, and we can probably show you how it works. And it works within the OpenStack. It's like it should work with real hardware. For more information on RedFish, there is that website of the standard body. They have all the schemas, all the papers, all the tools, and all the links. And that is probably it. Yeah,
I forgot to mention, but we are working on OpenStack, and OpenStack Bare Metal Service was one of the early adopters of RedFish. We support it for maybe a year already. OpenStack is cool.
Maybe referring to that composability thing and our OpenStack background, it's quite interesting to realize that what we do with the virtual machines with an OpenStack, we can compose virtual machines from resources we have on the compute nodes. This systems composability thing is kind of parallel to that, but it's done in real hardware. It's kind of an OpenStack, but in hardware. And we are probably going to integrate those two things together somehow, eventually. All right, so, yeah. Questions?
For me, I just kind of update to this talk because I had like real experience with CPU vendors. I would say like for HP, it also applies for Gen 9. So Gen 9 supports RedFish at some level, and also applies for Supermicro. But be careful with Supermicro because they could announce that they support RedFish, but half of the commands are just not implemented. So they will be in that JSON, but nothing actually working there. So just be careful with some. Also, you need to ask Supermicro what's actually working there. And I also have a question about the storage thing. So it's like a part of the standard, so what they announced. Because it could be tricky about the rate levels, because rate levels always implemented differently by each vendor.
Oh, I know, yes. Well, it is a part of standard, this whole storage thing. I was looking at it just yesterday evening, checking schemas. So yes, and HP is implementing RAID in generation 10 through RedFish. I know they're coming with us with a new driver. As to differences, yes, difference is huge. I'm not sure how they're handling it. Probably through OEM extensions.
Yeah, probably. And again, talking about OEM extensions, do you know any about developments like a unified library for to implement all those extensions in one library? Because it's kind of one benefit of using a DMI because you have a DMI tool, which actually internally handles tons of different standards. So you don't need to know about all deviations. You just have one command. But with the RedFish, you need to parse all the time all those OEM-specific things, and then you need to treat each vendor separately.
Yeah. So what we are doing, we have a library for RedFish. It's called Sushi, with Y in the end, just because. We are working on making it, it's in Python, and we're working on making it pluggable through entry points. Like you have this vendor string as a Python setup tools entry point, and then you install a vendor plugin library, and it catches this and inserts it into the whole Sushi structure. It's work in progress. We'll probably get there in half a year. But yeah, some problems. It's not like I'm not aware of a good CLI tool for RedFish so far. It's probably maybe I'm not just aware of it, but.
Well, me too, because just breaking myself, I mean, I have just a shell script which actually do the same. I just need to parse all the time all those specific things.
Yeah.
And just again, just the addition. So it's not about only components. I mean, when you calculate the system with the resources, it's also helpful. Like let's say you have a data center, and you need to calculate the amount of heat produced by the servers. And because you have a BMC combine like by recs or by the spaces, like which zone consumes most of energy. And this is also very handy and it's really super cool in terms of how it's implemented because you don't need to go to lower level of each DEC controller and get that information.
Yeah.
Vendors, oh, sorry.
Yeah.
Hi. So what you showed is a bit wide in terms of differentiating to a lot of it. And I'm wondering, like, what is defined as a non-goal for the project? Because in general, like you said, it's very extensible. You can do a lot of things with it. And then you talked about network devices management and storage device management. That goes into like the actual management portion of it, and not just the hardware management. Right? It's like the logical stuff on top of it. So what's the limit? Or do you expect it to cover all of the physical management of everything?
I guess the latter is correct. I think the limit is crossing the boundary of the generic operating system. Probably not like specific thing on Switch, but Windows, Linux, generic system. That's probably where we don't go with RedFish. Like, I don't know, changing your boot parameters for your Linux installation is probably out of scope. But hardware, I see people quite exciting to put more stuff in RedFish, especially given it's easy to extend and easy to discover, and people see it as a benefit that they can do anything with it. So I'm not sure where it's going to end. Maybe never. First question here.
Yeah, and the question is, in your experience with the different vendors, have they been shipping new capabilities in other words, are they waiting to rev the whole server generation before they introduce new RedFish capabilities, or do they do it with a patch to the out-of-band management card? How do they introduce these new features?
So just to repeat the question, not everyone has heard it. In my experience, vendors, how do they introduce new features, particularly RedFish features, as an update to existing generation or a new generation? It varies. I know they tend to prefer to introduce new generation, probably because rolling out an update to a generation may be a bit annoying. Not everyone installing updates, and then you have crazy time figuring out what hardware specifically supports. RedFish a bit simplifies it, but having discovery. And I've heard I think from Dell, they wanted to start doing incremental updates to their generation, but I'm not sure where it went. And RedFish is quite new. I think it's going to take a bit more time for vendors to really get into the idea that now you can update the thing just in a minor updates, right? Because it's discoverable. Users can just open this JSON tree and see if the feature is there or not. They don't have to be attached to a firmware version. But I'm not sure required there. Go ahead.
Is the access to the serial console and graphical console somehow included in this?
So serial and graphic console. Serial, I'm pretty sure is. Graphical, I'm pretty sure at least will.
It's a real extension, all of that.
Yeah, it's going to be better, but I hope.
And another thing, is the access to the RedFish only possible over the network? As for IPMI, you can use access from operating system.
So the question is if it's possible to access RedFish in band from the operating system. Not to my best knowledge. I think it was quite not in plans of doing that. And I'm not aware of any work in this field. Anything else? Okay, thank you very much. Hope you enjoyed it.
Ну да.
Только жалко, не получилось показать, как виртуалка запускается.
С Костей может быть интересно, а говорить он как раз...
I was trying to do the fun part of this.
Извиняюсь. Мы ничего не могли сделать.
Нет, конечно. Я так на них ворчу. Учат новым технологиям. ДПГ.
Nice one.
Как она?
I'm stamping it in half, right?
Yep.
Okay, so lots of time. Right.
Да теперь ты ведешь секцию?
Ну, я тут, собственно, железом распределяю.
Ну, какое железо?
Да, тут кроме ВГА ничего не работает.
Стал выписали?
Ты понимаешь, я думаю, они где-то тут должны оставаться.
Ну да.
know the game. I don't think you need my help here.
Yeah, I know.
Been there for years. Yeah.
I can use this one, right?
Yeah, probably. Yep.
Seeing that it's working, right? So I'm ready. 15 minutes. Yeah.
If there are some traces of pizza on the chairs, blame Project Atom.
It's what?
If there are some traces of pizza on the chairs, then blame Project Atom.
Kill those guys. Where did you get this from? I should have gone out of the room when I was in here.
As usual, as usual. Happened yesterday, like twice, I think.
Yeah, at least. Security purposes. Nothing is expensive anymore.
Select your payment method.
Come on, just the smart cover for my iPad is like 12 cents from like 1,200. Just a cover. But it's really fancy. I mean, it can fold.
How they say it in English? In Russian, it's красота требует жертв. And it's a game of words. You can understand it as like beauty needs some sacrifice, or might be not sacrifice, but actually victims.